Carrying on with section 10.2, iteration, and I'm not going to go through the method of what to do, I'm just purely thinking about why the method works. So if you're not sure how to do an iteration question, go back and look at the other video and practice a few, and then come back to this and see why the method works. So an iteration method is where we're trying to solve an equation that looks like this: f of x equals 0. Okay, so for some expression in x equals 0, and we rearrange that to a different equation, x equals some other function of x. So instead of having an expression equals 0, we have x equals an expression to do with x. Now f and g are different expressions, but these two equations are equivalent equations, right? This one was derived from this one, so the solutions to this equation are the same as the solutions to this equation. So this is the equation we're going to think about. And let's say this line here is g of x, y equals g of x. And let's say then this is the line y equals x, okay? So if I draw y equals x and y equals g of x, the point where those two things cross is the point where x equals g of x, okay? So the point where these two equations cross is the solution to this equation, and therefore is obviously the solution to this equation. So, how does iteration work? It works like this. We start with x0, and it has to be somewhere close-ish to the root, and we put that x0 into the function g of x. So in effect we've travelled from the x-axis up to the function here. Then we take the output of that function, that's this height here. The output of the function is the y-coordinate, isn't it? We take the output, and we make that the new input. Now this here is the line y equals x. So if I want to change the y output and turn it into a new x input, well, I just go across to the line and down to the x-axis, and that is my x1, okay? So I've made the output the input, and the way I've done that is that I've gone from the y-coordinate down to the x-coordinate and using the line y equals x. So I put x1 into the function, and that leads me all the way up to here, back to the function. So what I've actually done is I've gone from this x0, I've gone up to the function, I've gone across to the line. Then I've gone up to the function. And if I do the same thing, I'll go up to the function, across to the line, up to the function, across to the line, and so on. And can you see that there's a staircase here that's getting smaller and smaller, but closer and closer to our root. So that's how this one is working. This is called a staircase diagram. And the other version of this is called a cobweb diagram, and it works exactly the same way. And I'm going to try and copy, in fact, you know, I won't even try and copy it. This is quite difficult to draw these correctly, as my classes always find out when I'm standing at the board trying to draw them and not make mistakes. So this black line here is our g of x, this blue line here is y equals x, and the iteration method takes us from x0, we go to the function, then we go horizontally across to the line, vertically to the function, horizontally to the line, vertically to the function. And can you see what's happening here is that instead of going in a staircase, we're spiralling in. And this is often called a cobweb diagram. Looks a little bit like a cobweb, doesn't it? When you first learn quadratics, we teach you how to factorize quadratics. And you think everything can be factorized, and then suddenly we tell you, oh, actually, no, we've been lying. There are questions where you can't factorize a quadratic. Iteration's a bit the same. We show you iteration, we show you when it works, and we give you questions to do, and you always end up with a solution. But actually, there are plenty of solutions, plenty of cases where the iteration method won't work if you don't do things exactly correctly. And here's an example of that. Here's my black line being g of x and the blue line being y equals x. If I start here at x0 and I go vertically to the curve, horizontally to the line, vertically to the curve, horizontally to the line, can you see that this sequence is not getting closer to the root? Even though we started close to the root, it's getting further and further away, and it's spiraling off, okay? So you might be lucky, you might be unlucky in real life if you try and use an iteration method. But for the questions, as long as we're aware that sometimes the sequence will not converge, will get bigger and bigger, it will diverge, as long as we're aware that sometimes it'll diverge, sometimes it'll converge, that's all we need to know. Most of the questions I would expect, they will ask you to find a solution to an equation by iteration. It's not impossible, they'll ask you to explain this sort of thing though. If you're interested, the difference between the equations where it converges and diverges, if you look at this one, look, the gradient of the black line is much steeper than the gradient of the black line here and the gradient of the black line here. And actually it turns out that if the gradient is small, iteration works. If the gradient is big, the iteration doesn't. And what do we mean by small or big? Well, we mean bigger than 1. You know, what 1 counts as 1 or smaller counts as small, -1 or smaller counts as small, and outside of the interval between -1 and 1 counts as big, and iteration won't work. That's the end of the iteration.